Right. Good morning, everyone, and welcome to the Advanced Database Systems module. And last time we started looking at query processing and query optimization, and we were discussing the first part of that. Simply, we looked at how we can use heuristics um, in query optimization to improve our queries. And today I'm going to briefly talk about the next one, which we call cost-based query optimization. And then I can also explain some of the applications in practice using MySQL. Okay, so having said that, let me quickly go through what we have discussed so far under the query processing and also use of query optimization. So given a query, I told you like the first part would be like you understand what should happen within the query. So the initial part would be it'll scan, pass, and validate whatever the query given in SQL form, and then it'll put into a form that you can use optimizer to optimize the query, and then it'll generate execution plan, which uses query code generated to code to execute the query, and then it'll submit it to the runtime database processor, and you will get the query result. So having said that, we discuss about use of our company database, which is the database we have used throughout the Navates book for explaining how the query optimization and done. Now, the first one we need to understand is given a SQL statement or given a query, you need to understand the primitive operations we discuss with the relational algebra, which means when you're given some query like this, in this particular case, we have asked for every project located in Stafford to list the project number, controlling department number, and the department manager's last name, address, and birthday. So if you go through the query carefully, you should notice that we have to join three relations, which means we have to join project, department, and employee. So in that particular case, we know we have to have two join conditions and one selection conditions to answer this query, right? So that's the first thing. Now, what we could do is the next thing is we can come up with a query tree, something like this. This is a graphical representation which explain you how, for example, relation are joined. Now, for example, you can see here we have a project relation, the department relation, and here we have a select clause or select statement is applied, which means we actually filter out all the projects in Stafford, and then we join together with project and the department. Then you join with the employee, and then you will actually filter out all the what we call fields that you need for the final answer. Now, depending on how you put the query tree, you will get different answers, different query performance, right? So this is what we are interested in. When you write a query, right now, maybe you are wondering, I mean, writing some answer, getting answer. I mean, getting answer is not the final aim. The next aim would be like how faster you can provide the result. So that depends on how you write the query. So this is we are trying to understand here. Okay. So what we discussed this is we discussed using last time use of various heuristics to handle this situation. So given example query, we discuss how we can find the final tree that is efficient to execute. Now, to understand that one, what we discuss is, okay, given this very first query, given that we have to select last name from employee works on project. That means employees are works on different projects where the project name is given with a particular project number, and also the birth dates after 1957. So if you want to answer this query, and if you initialize the query, which we call, this is actually more generalized version. And what you see here is what we call the Cartesian product between the employee and the work zone, which means all possible combination of the records. And then you do this with the project. But then to select the validated, tuples, you have to have uh, all the joint conditions. So with these two joint conditions, you filter out what is relevant, and then we have some two selection criteria. Project name should be Aquarius, and then the birth date should be like after 1957. So once you filter out this, then you will select only the last name. So that could be the easy one, but you will notice that this will generate lot of unnecessary records. A Cartesian product means, if you remember from your previous discussion, right, it will generate all possible combination, which is sometimes not relevant for us. So therefore, in query optimization, the very first thing we discuss is, when you have a situation like this, you better use select operation. You move select operation down in the decision tree, query tree. So why we are saying here, this is because when you send queries down in the tree, right? So what happens, you will get a more optimized or more less number of records because you have the selection. So the next step would be, right, much better than this one would be, right? You move down, for example, this birth date is relevant to employee. So move down it here so that you are not going to consider all the employees when you are joining. So in that way, we can reduce a quite number of, you can save a lot of records here. Similar to that, here we have another selection condition we put down here. So that means you will select only the project acquirers. So that means our selection will be smaller. Similar to that, once you do the cross product, Cartesian product between the employee and work zone, we can have this, joint condition where we match employee social security number with the social security number, so that the number of result point is also smaller. And similar goes like this. So in that way, what we did here is all these selection statement, we move down into the relevant places so that we reduce the number of tuples. Next one is, you can apply more restrictive select. What it means, simply you can see that, okay, before you come here, right? So this is the smallest one we are going to have. So let's have this first. So that means this is more restrictive because you have just one record here. Therefore, we will put this in down in the tree. So you will get this. So instead of starting with the employee, this time we start with the project, we combine with the work zone, and then you combine with the employee, so that you will have a minimum number of, records to start with. The next thing would be the Cartesian product is a problematic operation, because Cartesian product, what you will do is you combine all possible combination and then you select relevant records. So instead of doing this, we can use join operations. We can use here, right, here and here, which actually saves, but you can save the query execution time, right? And the final tree would be that you can move even the project, because you don't need all the fields as well. For example, you can see here in previously we have not filtered anything, but here we say from this point on what we need is a project number. And here what we need is only this social security and the project number. So you have reduce the number of attributes as well. And once you combine, you select only the employee social security number. Similar goes here as well. You don't need all the attributes. What you need is a social security number and the last name, and then you join it here and you filter only the last name. So in that way, you will have a optimized query. Right. Now, having said that, uh, that's what I actually thought of discussing query optimization. And what we need to do is you need to understand when you write a query, how do you put this down in SQL statement, which I'm going to explain you um, after finishing the next part also. I will take some MySQL codes to show you how you perform this. Okay. Having said that, let's move on using selectivity to discuss query optimization. We discussed the heuristics, optimization algorithms. So what we said was you can break these select operations, and then you can go put it down in the tree to reduce the size, and then rearrange your nodes for efficient execution, and then you can do that. Right. Okay. So having said that, we can move on next part, which is cost-based query optimization. What do you mean by cost-based here is cost of execution in query, because depend on what execution strategy you use or strategy you select, there'll be a cost involving it in this particular case. So for example, the cost of accessing your hard disk or memory, and also other networking, because if the data coming from another place, that also you need to think about it. So in a cost-based query optimization, one of the issues that you need to face is how do you find the cost we call cost function, and then what are the number of execution strategies that you need to consider. Right. Now, when you talk about the cost components, there are different costs we can consider. One thing is when you want access in secondary storage, that means your hard, for example, that you need to discuss. Then first one is access to secondary storage, and then to store the data. Then you have a cost. Then there's a cost for computation, memory usage, and communication. So when you look at different database management system, we have not discussed this earlier, that they have focused on different costs, and that's why people prefer some database management system over the others. So that's the idea of cost component. Right. Now, there are like different information we use for the cost function. For example, size of the file, we can talk about number of records, the record size, number of blocks, blocking factor, and so on. And then information about the indexes and indexing attribute, which means like, for example, if you use particular attribute where filter your data, then that particular attribute could be make it as an index because we want the results to be faster. So that's what we will discuss here as well. So then you can have number of levels in what we call the multi-level index, number of first level indexes, number of distinct value, selectivity, and selection card. So those are some of the information we use when you are using cost estimation. Okay, now I think I discussed the very first theory part. Maybe then we can connect to MySQL, and then we can see how we can work on this problem. But before that, let me ask you like, okay, okay, now if I see show databases, I can see the company database in the list. So let's use company. And now I have to create the employee table. So for that, what I have to do is I have to create the employee. And I hope you remember right. Let me give you the coding. Right. Let's see whether it's working. Okay. Create table employee, first name, middle initial, last name, social security number, birth date, address. Okay. Sex, salary, supervisor, social security number, department number, primary key. So that's enough. Okay. Describe. Okay. Maybe show tables. Okay. I can see employee, describe employee. Okay. So that this is working, right? Good. So the next one that I would like to have is other table, the department. In the department table again, okay. So let's put the description. You're going to create the table. Okay, department name, okay, manager, manage start date. Okay, that's fine. Okay, so now we have two tables. Describe department. Okay, so that is also there. That third one, we can have department locations. So in department location, if you remember our database, we have a composite primary key. That means there are two parts where we combine both the department number and the department locations. So let me put that one as well. Okay, we have company create table department locations. Okay, that's working. So now we can describe department locations. Right. Okay, we have done 3. Then we have project. Let's put up project. Remember, I'm not putting any foreign key constraints here to just to simplify this. Let's see. Okay, we'll put table project. Project name, project number, location, department, and then primary key. That's fine. Okay, then describe project. Okay, that's it. Okay, good. The next one we have to create works on. It works on again, it's a composite primary key where we have employee social security number, project number is the primary key. Works on. Okay, that is also fine. Then the last one is the dependence. So let me put dependence. final one, we put okay dependence. Yes, show tables. Okay, this is fine. We have all these the data points that we need for our database. So this will show you complete company database structure. Now that we got company database structure, the next one is we need to insert the values. So let me see whether I have the data with me. Okay. Okay, so I think I found it. So let's put up some values and see whether this is working without any problem. So I'm going to insert all these insert records. Yes, okay. So I have entered data for employee. So let's say select all from employee. Okay, so okay, we have data. No issue. So let me put then the department also. Okay, we have department information. Then let's have a select all from department. Okay, that is also working. Then let's put department locations. Then select all from department locations. Okay, we have everything about up to this point. Now we have to put on information about the projects. And then select all from project. Done. We want to now put on, okay, works on. Okay, there's an issue with the last one. Null value is not taken. Let me put 0 for the time being. Okay. The reason is I have defined the column as not null. If that is the case, you cannot have null values. I hope that part you understood. The last one is dependence. So let me put dependent values. Okay, well, I think I have populated my database. Now we are getting ready to write some queries and just, see. For example, I hope you have done simple queries like, okay, select let all from employee that you already know. So maybe I can say select first name and last name from employee. So that is simply you working on one table. So let's say we can combine, okay, employees with let's say work on particular project where they belongs to department number 5. So how do you write that? Let's say I want to retrieve. Let me put, see like this, select all from projects. Okay, sorry, select all project. Okay, let me give a query first. Can you tell me a query to, let's say I want to extract names and project names of those who works in department number 5. So department number 5, you can see there are 4 employees. I just want to list their names and then their projects. Can you give me the query? What we have in projects, we have PNAM, okay. So we can say, okay, sorry, PNAM. Right. So here is we combine everything together. Right. But we don't need everything, right? By what I said was what I need was only the select first name, sorry, F name, L name, and what was it? Project name, P name. Okay. I will go down from employee, comma, works on, comma, project. Where, okay, we have social security number should be equal to employee social security number. Yes, and project number should be equal to P number, and department number should be equal to 5. Okay, so this is exactly what I have asked, right? Let me see my answers. Okay. Okay, Ishan used the join statement. Perfectly all right. Then one also gave me the answer using join. That is also perfectly all right. So let me give you the alternative one. So for example, if I want to answer this, uh, we can use join operation as well. So what we need to do is, let me try to put it in the join operation. Same thing. You know that you can write uh, same answer in various different ways. So let me put the join operation, but we say select F name, L name, P name, right? So these are the 3. From the first one is employee, we can say join. Which one we are going to join? Okay, so we need to join what we call works on. Works on, yes, on, then we put the join condition, right? So what is the join employee and the works on? We have the social security number should be equal to employee social security number. So that's the combining both employee and works on. Then to that we have to say, okay, join. We want to join what is it? We want to join project on, then the condition we have to say project number equals to project. Okay, that's it. And then finally we need to make a selection, because the we can say where the department number should be equal to 5. Yes. Anyway, good that at least 2 of you, right? Um, so this is exactly what we are trying to understand, how different types of queries will execute differently. That's what I said, right? Yes. So there's a statement which you can actually use to check whether to use join or not, right? Um, so for example, I have used, two queries, but gives you the same answer. Now the question is, how do you select this, right? Okay, so then there's a, in a, we have to identify how it execute. Now to understand this, how exactly these two execute working, and that is what we want to discuss. So what you can do is you can use explain. For example, I will go to the first one. I will say, okay, explain, PLA, like explain. We will say, okay, select first name, last name. And then let's use our first way, from employee works on project. And then, okay, where is it? Okay. So now this table will tell you exactly what indexes and how, exactly it uses, what keys it uses. That information is given here. So when you put that, simply what we need to understand is explain will give you how, uses the join operations, or in this particular case, how we actually combine different tables, right? So for example, here you can say type column here indicate that, okay, type of combination, and then ref, for example, indicates that, okay, it's you how do you join this, and then you have some extra information, how you which uses which columns uses the indexes. Similar to this, you can try this to the next query as well. So let me use explain again. So I'm going to use explain. This time I'm going to use the join ones. Let me use join. So you can see, we will have different ways of using this, but it looks very similar in this particular case because we use similar method. But let me give you another way of writing this same query. Maybe I will use a subquery for this. Let me see. So what we could do is I can write the same thing using subquery. So let me see how we could do this. Okay, so let me say select F name, L name, and P name. And then we will use I will use E dot name. I will explain why I'm using this. E dot L name, and we have project name from employee. We have employee works on project. It should be Okay, we are combining this project name and this. We are okay, employee. Sorry, the previous one I had to change a bit. Okay. Yeah. So since we have time's up, let me finish. But what I'm trying to do at the end is use of a subquery to do this, right? So we will discuss this in the next class. But what I'm trying to do is use of explain. Now I have showed you like what you need to select to understand what is happening inside in the query and how the query is executed. And this is what we need to understand. And the two examples we have noticed that it's exactly the same, irrespective of whether we have join operation. But what I want to explain is actually this depends on the way we write the queries. So for example, the example that you have learned use of subqueries, you can use it to understand this the difference. I will show you in the next class, right? So make a note of this. So I will continue from this point onwards. But what I want you to do as a small homework is you set up this database and come. The data will be available in the textbook, the everything. So when you write, you should be able to get the way I have arranged. So make sure that you set it up in your side and come for the next session. Right. Let me finish for today then.